Okay, on to next page. So, let me show you why this is useful. If I'm trying to solve for x here, this isn't a special right triangle. It's not a 30, 60, 90. It's not a 45, 45, 90. So I can't use those. I can't use Pythagorean theorem because I only have one side. So I'm not going to be able to solve for x with Pythagorean theorem. But I can use trigonometry. I can use SOHCAHTOA. Okay? So that's what I'm going to want to do. All right, so I'm just going to write out SOHCAHTOA so I have it handy here. All right, so what I want to do is place myself at one of the angles. I never want to be at the right angle. I want to be at one of the acute angles. And since only one of them has a number, I'm going to put myself at the 34-degree angle. Okay? If I knew this angle, which I could actually find really quickly, I could put myself down there too. But if only one of them is marked, put yourself at that angle. Okay? And then I'm thinking about the parts of the triangle. I've got the hypotenuse down here, but that doesn't have anything marked. So I'm only going to label the parts that have the 8 and the x. So this would be the opposite leg, right? So this is opposite, and this would be the adjacent. Okay, so then I'm going to write a trig ratio from the 34-degree angle. I have a really important decision. Should I use sine, cosine, or tangent? Only one of them is going to work. So I'm going to look for the one that utilizes opposite leg and adjacent leg. That's the tangent, right? So I'm going to take the tangent from a particular angle, from this angle. I don't know the name of that angle. I don't know if that's angle A, B, or C, or whatever, but I know it's a 34-degree angle. So I'm just going to say, hey, I'm at the 34-degree angle. So I'm taking the tangent of 34 degrees, okay? And that's going to equal opposite over adjacent. So 8 over x. Okay, I'm going to want to solve this for x now. So you could multiply both sides by x. Don't multiply both sides by 8, then I'll just have 64 over x. So I could clear the fractions by multiplying both sides by x and then dividing by the tangent of 34 degrees. You can also use my patented invention called the incredible switch. When you have a variable in the denominator like that, you can just switch those two, and x is going to equal 8 over the tangent of 34 degrees, okay? All right, so at this point we're going to need a calculator. This is my exact answer, but I'm going to get a better answer. Well, I'm going to get a decimal approximation of this. I shouldn't say it's better, but I'm going to get a decimal version of this, okay? So first thing, you need a scientific calculator because you need that tangent key. On these calculators, it's right here, okay? So I'm going to type it in, tangent of 34 degrees, whoops, 34 degrees, and hit enter, and you should get this decimal. Some of you might get a different decimal. Hang on one second, take this off screen. Okay, so some of you might have gotten this, negative number. So that's because there's two different modes you can put scientific calculators in, degrees or radians. So we're measuring our angles in degrees at this point, so we want degree mode. We'll do radians later, but you want your calculator in degree mode. So you want the top number here, okay? So if you hit mode on any calculator, any scientific calculator, somewhere you should be able to toggle back and forth between radians and degrees. We want degrees here. And once you have your calculator set, it'll stay in that mode. But it's good to be aware of it, especially if you're using someone else's calculator or this is the first time you've done this. Okay? So there's the tangent of 34 degrees. I'm going to do 8 divided by that. You can just type in 8 divided by tangent of 34. On some calculators, you should get about this. But if you can't on yours, then you might want to find tangent of 34 first, and then do 8 divided by that 0.674 number. And the more of the decimal you use, the better. I would try to avoid rounding as you go. Right, so that gives me a good answer there. So I'm going to call that 11.86. I'm going to go to the nearest hundredth. Okay, and that means, you know, this picture obviously isn't to scale, but that means that side would be about 11.86. Okay. All right, let's try another. So on this one, we want to be down here. Okay, this is opposite. This would be the hypotenuse. So I'm using the opposite and the hypotenuse. So looking back up here at SOHCAHTOA, opposite and hypotenuse, that would have to be sine. So I'm at the 23-degree angle. Opposite is 7. Hypotenuse is x. Okay. And then I'll do incredible switch here to isolate the x. Okay. And then I put that into my calculator. And then I got 17.92 roughly. I'm usually going to go the nearest hundredth, so for me, that could be our default. Unless you're directed otherwise, let's do that. Okay. All right. Now let's apply this to a word problem. Okay. Ed is flying a kite on a 100-foot string. I'm going to end up with a triangle, a right triangle in this picture. So let's draw ourselves a picture. All right. So here's Ed. Okay. And then we've got the really, we don't want Ed holding the. Let's say Ed ties the kite to the ground. I didn't put that in the problem, I know, but let's say he ties the kite to the ground. So here's my kite. Okay, and then it's a 100-foot string. All right, and the angle of elevation from Ed to the kite. So that means this angle of elevation, if Ed looked up towards the kite, like from where he tied this to the ground, I guess that would be 32 degrees. Okay, we're supposed to find the height of the kite. Okay, so assuming that the ground is flat, then we've got a right triangle. Okay, so there's my situation. Now it looks a lot like the last problem. Okay, so opposite is the x, and this is the hypotenuse. So SOHCAHTOA, that's sine again, just like this one is, right? So I'm at the 32-degree angle. Opposite is x. Hypotenuse is 100, okay? I don't want to do incredible switch here. You could, but then I just get 100 equals x over sine of 32 degrees. So that's not really going to do me any good. It's not going to isolate x. So in this, since I don't have a variable in the denominator, I'll just clear the fraction by multiplying by 100, okay? So that will isolate the x. Notice this is not the sine of 3200. Don't multiply the 32 degrees by 100 because sine of 32 degrees is a number in itself. Your calculator can tell you what that number is. But I want to write this as 100 of sine, 100 times sine of 32 degrees equals x, okay? And then, depending on your calculator, you might need to type in sine of 32 first and then multiply by 100. On these graphing ones, I can just type it in like that. So going to the nearest hundredth, this would be 53.00 if I'm going, no, never mind, it'd be 52.99 going to the nearest hundredth. 52.99, okay? And this is going to be feet just because the other units in there are also in feet. Okay, let's try some more. All right, so this is a straight up SOHCAHTOA problem. I'm down here. And so I've got the adjacent and the hypotenuse in SOHCAHTOA. The only one that uses adjacent and hypotenuse is cosine. So this is cosine of 20 degrees equals 3 over x. I'm going to do incredible switch here. I'm letting everyone use incredible switch for free for the time being. But then later on, there will probably be a fee. But you can use it free, a trial period for now. Okay? All right, 3 divided by the cosine of 20 degrees. All right, and that's about 3.19. If you ever are doing these and you get negative answers, then that might be it might mean that you're in radian mode. Okay, it's not always, you're not always going to get negative answers in radian mode, but if you get strange answers, check if you're in the right mode. And if it's not that, double check your work. Okay, so I'm going to find the measure of this angle here. So this symbol is theta. It's the Greek letter theta, and we use that for unknown angles. often, because it'll get confusing once we get on an XY axis if I just call that X or Y or whatever. Okay, so this is just often used for an unknown angle. All right, so we want to still do this with SOHCAHTOA. I'm going to put myself at that angle. I don't want to be at the right angle. I don't want to be at the unmarked angle, so I'm down. Thinking SOHCAHTOA, I've got adjacent and a hypotenuse, just like I did on the last problem. So I'm going to use cosine again. So cosine, I'm at the theta angle. Okay, cosine of theta equals 4 over 5. Okay, so this doesn't mean that that angle is 4/5 or 0.8. It's not. Okay, so what I want to do is isolate the theta somehow, and the only way to do that is with an inverse trig function. Okay, so what's going to happen when I use an inverse trig function is it's going to switch the position of these two things, and then it'll isolate the theta. Okay, so the inverse of cosine, the way I'm going to write that is like so. Okay, so I've got cosine to the negative first, but it really means inverse cosine. Okay, sometimes you might see arc cosine. That means the same thing. All right, and then that's going to switch the 4/5 and the theta. Okay. Yeah, so this is inverse of cosine. Okay. All right. And then on your calculator, we can put that in there, okay? And it's going to be, as long as you have a cosine key, you're going to have an inverse cosine key. Almost always, it's going to be the superscript. So you see the little blue writing on my, so what I'm going to do is hit second and then cosine to get the inverse cosine. Okay, so let me zoom out again. In almost all calculators it works like that. So I'm taking the inverse cosine of 4/5, which I could type in 4 divided by 5, or it's just 0.8. It's the same thing, right? And I got about 36.87. So that means this is going to be, since I'm in degree mode, this is going to be about 36.87 degrees. And that kind of seems reasonable, right? That could be a 36-degree angle. Sounds reasonable. Okay, let's try another like that. So anytime we're looking for an unknown angle, we're going to end up using an inverse trig function. Okay, so from here, I've got opposite and adjacent. And so I'm going to use tangent. That's the TOA part of SOHCAHTOA. So tangent of theta equals 3 over 8. Okay, and then I'm going to use inverse tangent to switch the position of those two things. And now I've got something that I can plug into my calculator. Okay, and so just hit second tangent for inverse tangent, and I'm just going to type that in as 3/8 like that, and I've got about 20.56. And that's in degrees, right? I'm measuring in degrees, so I want to put the degree symbol there to show it's degrees, not radians. Okay. All right, so that's inverse trig functions when we have when we're finding unknown angles, and there's something else called reciprocal trig functions, and these sometimes get confused. Okay, so here's my three basic trig functions, but let's say you wanted to do hypotenuse over opposite instead of opposite over hypotenuse. Well, you could do that. It's called cosecant. Okay, so I put this right by the sine one because it's the reciprocal. So that just means you flip it upside down. So this would be the hypotenuse over the opposite, cosecant. Here's the 3-letter abbreviation for that. Okay, the reciprocal of cosine is secant, and that would be hypotenuse over adjacent. Okay, it's flipped from that, right? And cotangent, flip that, and you get adjacent over opposite. Okay. If you need to memorize these, which one goes with which, think of them as copairs. So if I kind of separate them like this, these are copairs. Like the top two are a copair because there's one co in there. So they're a copair. And that's not a technical term, but that's a way to remember it. Each one of these pairs is going to have one co. So in my second group, there's one co, right? In my last group, there's one co. All right? So if you can remember that tangent and cotangent go together, which is pretty easy to remember because this has tangent in it, then it makes it easier to remember the other two, because when I'm thinking reciprocal of sine, well, I know it's not cotangent, so it's either secant or cosecant. Only one of them has a co. Then I remember it's that one, and the same thing works, and they all fall into place. Okay. I'm mostly going to be using these three because you can do all of these any problem that you could do like with tangent, you could also do with cotangent, but why not just use the originals? There's less to remember then. But you could have done this problem. You could have said the cotangent of theta would equal 8 over 3, and you could solve it that way as well. Okay. Okay, sorry if I had a weird edit there. All right, so there is my new trig functions, the reciprocal trig functions. So on this next problem, we're going to be asked to write the trig ratios for cosecant, secant, and cotangent. So I need to know, hey, this is hypotenuse over opposite. This one is going to be hypotenuse over adjacent. And then this is adjacent over opposite. Okay, so I'm going to use that from the last. Okay, so if we're up here, this is opposite, this is adjacent. So I can do cotangent right off the bat. So opposite is 70, that goes on bottom now, and 24 goes on top. I do want to reduce that, so let's go ahead and do that. That's going to be 12 35ths. You can divide them both in half, and then there's nothing else we can divide it by. Okay. But I can't yet do the other two because I need the hypotenuse, but that's okay because I can do a little side problem, right? If I call this C, a squared plus b squared equals c squared, I can use Pythagorean theorem. Sorry about the bell there. Okay, so 24 squared is 576. 70 squared is going to be 4,900. And 5,476 is c squared. Okay, I'm going to take the square root both sides, and then c is going to come out to exactly 74. So just happen to be an integer. That makes it nicer. Okay, otherwise I'd want to use simple radical form if it wasn't an integer. Okay, and now I can do the other two parts. So hypotenuse over adjacent, that's going to be 74 over 24. Okay. Hypotenuse over opposite is going to be 74 over 70. Okay, and I'm just going to show you a quick little way to reduce fractions on here. I think I've shown this probably before, but 74 divided by 24, that's a now it's a decimal, but if I hit math button right there and choose fraction, it'll turn it back into a fraction, but now it's reduced. So 37/12 is this one. Okay, and I can do the same thing with 74 over 70, even though these wouldn't be that difficult to reduce by hand. Then I've got 37 over 35. Okay. All right, next problem. In a right triangle, sine of theta equals 5 over 6. So sine is opposite over hypotenuse. So this is going to be opposite over hypotenuse. That's going to be important. Okay. So what I'm going to do is draw myself a little right triangle. However you want to make it, just make sure it's a right triangle. And then I'm going to put theta in one of the two corners, the two acute angles, and I put mine there. Okay. And if I'm down here, then opposite is going to be here, right? So that means this has to be 5, and the hypotenuse is right here, okay? And then I've got myself a visualization. It's going to make the rest of the problem a lot easier. Okay. So what I need to do, I still need to find the adjacent. So I'll call this x. So I can say x squared plus 5 squared equals 6 squared. And I'm off screen. There we go. Okay. I'll subtract 25. And then take the square root, and I'm just going to leave that as a radical. It's in simple radical form, so this would be root 11. Okay? So I've already got sine. That's 5 over 6. So my co-pair, it's going to be cosecant, is the reciprocal. So I just need to flip that upside down, right? 6/5. Okay, so there's one of them. Now I can also find cosine because I've got adjacent, and this would be adjacent, right? And hypotenuse, so root 11 over 6. Okay, and that's in simple radical form already, so there's a second one. Okay, the co-function of the reciprocal of that, the co-pair, isn't going to have a co in it, so this is going to be the secant. And then I'm going to flip this upside down. Okay, and this one's not quite ready to go though because I've got a radical in the denominator. So I want to take care of that by cloning a twin for the 11. So this is going to be 6 root 11 over 11. Okay, 3 down, 2 to go. All right, tangent is next. So that's going to be opposite over adjacent, 5 over root 11. Okay, I do want to put this in simple radical form, but actually before I do that, I'm going to flip it upside down because when I flip it upside down, it's in simple radical form. So there's my cotangent. Okay, but I still want to simplify this. So that's going to be 5 root 11 over 11. And then I've got all 5 of the other ones, right? I had sine to begin with. I used that to create the other. So you draw yourself a little picture, find the missing side, and then you'll be able to fill in the trig ratios. Okay, let's try one more just like this on the next page. So we're given sine again. Okay, so I'm going to draw myself a little triangle here. I'm going to put theta right there. We've got opposite over hypotenuse. So opposite here would be 4 right there. And hypotenuse goes right there. There's my 11. Okay, let's find this last side. So do a little Pythagorean theorem here. Oops, equals 11 squared. Okay, I'll subtract 16. And then take the square root of both sides. Okay, and let's see if there's any twins in there. I can divide by 5. That's 3 times 7 times 5 is 105, but there's no twins in there. So this is in simple radical form. Okay, and now I've got everything I need, right? Because I've got opposite, hypotenuse, and adjacent. Okay, so if sine theta equals 4/11, then its reciprocal, cosecant, is 11/4. Oops, 11/4. Just flip it upside down. Cosine, now I can figure that out. Adjacent over hypotenuse, that's root 105 over 11. Okay, that one's good to go. The reciprocal of that is going to be secant. So I can just flip this. But then I still want to go simple radical form. So that's 11 root 105 over 105. And that is in simple radical form. Whew, just barely made it with space there. Okay. And then, okay, so there's another. And then tangent, opposite over adjacent, 4 over 11. And then cotangent, flip that whoops, not 4 over 11, 4 over root 105. I'm hurrying because I have a class that's about to come in. All right, and I want to finish this before they do. All right, so this would actually be 4 root 105 over 105. Okay, and then cotangent. I can flip this around, but I'd rather flip that version around because that gives me root 105 over 4, which is good to go. Right? If I were to flip this around, then I'd still have to simplify I'd have to rationalize the denominator. Okay? And that's it. That's all I got. See you next time.